Hey everyone, welcome to my YouTube channel where I will be doing some math tutoring videos. This will be the first video of my AP Calc tutoring video playlist. And the first topic we'll be looking at is continuity. So the idea of before we know continuity, we need to know what a function is, which may have been covered in previous algebra classes, but just to be safe, I will cover it again in this video. So a function is a certain type of equation that if you were to graph a vertical line through it, it would only intersect with the graph once, or no times. If it intersects more than once, it is not a function. Take the equation y is equal to x squared minus 1, or just any parabola. I said x squared minus 1 because that is the closest to whatever I drew here. If I were to draw a vertical line through it, notice how it only intersects once, and I can do this just about anywhere on the graph, and I would still only have one intersection. That means that the parabola is a function, and I can do the same thing with a line, and you would get the same result, and just about any polynomial, you would get the same thing. If I were to do the same with an exponential function, y is equal to e to the power of x, I only get one intersection like before. And if I were to do something with the natural log function, y is equal to ln x, wherever the function is defined, I only get one intersection. But take the equation of a circle. I'm going to draw a line through a random point in the circle, and it intersects twice, meaning that the circle is not a function, but rather a relation. So any function can only have one y value for each x value when defined. Or to put it more simply, if you draw a vertical line, more than one y value means it's not a function. That's probably the easiest way I can say it. So now we know what a function is. Continuity only applies to functions. But here the test to see if a function is continuous is not really that difficult. I'm going to draw a random function. We'll just say y is equal to x from the previous example of what is a function. If I can draw this line without lifting my pen up, it's continuous. Here it might be a poor example, but just to prove my point, I will draw another parabola. So y is equal to x squared. I did not have to lift up my pen for this, meaning this is also continuous. But this does not mean that every single function is continuous. If I were to draw something like y is equal to 1 over x, it's split into two parts. One where x is positive, meaning on this side of the axis, the other where x is negative, meaning on that side of the x-axis. But I had to lift up my pen to draw it, meaning it's not continuous. Likewise, if a function has a hole in it, it's not continuous because the hole implies that it is not defined at that certain point. These two are discontinuities. So now we know what continuous functions are. Let's go into the types of discontinuities you can encounter. So the most common discontinuity you'll probably encounter is the vertical asymptote. This happens in an equation where if you were to have a numerator and denominator and you use a certain point on the equation, the numerator would not be 0, but the denominator would be 0. Take the equation y is equal to 1 over x. When x equals 0, you get y is equal to 1 over 0, which is undefined. Therefore, if it's undefined, you cannot really graph it. So that's one type of discontinuity. The second type of discontinuity is the removable discontinuity, or the whole, which might be easier to remember. This happens when both the numerator and denominator are equal to 0. So if you were to have something like y is equal to x squared over x, you might think that this can just be simplified to y is equal to x. Not exactly, because when x is 0, you get 0 over 0. This is indeterminate, meaning that you would most likely get a whole if you were to graph this. So it would look like a normal function, but at a certain point you would have a whole. So this graph would be something like whatever I'm about to draw. While this graph over here, the vertical asymptote, would be something like what I'm just about to draw right here. Notice how it never intersects this axis over here. In this case, the function I drew doesn't exactly match the equation I mentioned, but that's more due to poor drawing skills on a laptop than because of any mathematical problems. And the third type of discontinuity is the jump discontinuity, meaning that if you've encountered piecewise functions, this might be easier to depict. But basically speaking, for a certain part of the function, you have something, and then it just jumps to a totally different point and starts from there. In this function I drew over here, it jumps all the way from here to there. In this case, not continuous. And in all of these three cases, well, in two of them at least, you also don't have limits. The limit does not exist for the vertical asymptote and the jump discontinuity, but it does exist for the removable discontinuity, because in most of these cases, the removable discontinuity equations can be factored into something more simple, and that can be used to find the limit. And what exactly is a limit? Well, that will be discussed in the next video. But until then, stay tuned, and thank you very much for watching.